Alright, today we're going to be looking at 5.6, creating best fit lines. This is something that we've already done together in class, but if you've missed those days or missed those notes or need a refresher, we're going to take a look at it using this graph right here. This graph, we have some data that has been already plotted. We don't actually know what x is and what y represents, but we've got some data for them. This is saying that when x equals 1, y equals 2. When x equals 1, y could also equal 3. When x equals 2, y equals 4, and so on. Now, this is technically not a function, but we can still provide a best fit line for this data. So we're going to follow these steps here. We're going to draw a line. We're going to hit 2 points in a y-intercept. We're going to find the slope of the points, and then finally we're going to write the equation of the line. So if we're picking 2 points, we're going to try to pick 2 points where if we drew a line between them, we'd have about the same number of things above and below the line. So if I were to pick, let's say, this point down here and this point over here, we'd run into a little bit of a problem because this line doesn't quite work. We've got only dots that go way above it, and it doesn't seem like it accounts for these dots up here, so we're not going to use that. If I pick this dot and this dot, okay, we're a little bit closer, but we still have so many dots underneath. So in order to create a best fit line, we're going to look for the same number of things above and below. Now, if I pick this dot down here and this dot up here, well, it looks like I'll have 3 dots above, just barely, maybe 1, 2, 3 dots below, and this one looks like it'll be pretty close to exact. So it might not be perfect because we don't have quite the right number of dots to make it an even spread on either side. But this looks like a pretty good fit. This one's not too far off. And the ones that are furthest away, like over here, are balanced out by some that are a lot closer. So this is what we call an outlier. But there's one part of the direction that I didn't account for here. It says to hit 2 points and the y-intercept. So I need to make sure that I do that. Hit 2 points and the y-intercept. So I'm going to start up here instead with this dot and go all the way down until I hit the y-intercept. So I've gone through 2 points. I've gone through the points of 1, 2, and the point of 5, 7 to create my line. And I have a y-intercept that's somewhere right in here. Now we can make a prediction for what the y-intercept is. We can make a prediction for the slope, and they can be pretty close. But what we're going to do next, we're going to write the equation for this. So we hit 2 points in the y-intercept. We're going to do 2 things. We're going to find the slope of the points, and then use that slope in order to write the equation of the line. Now scroll down just a little bit. And remind you that the points that we used were 1, 2, and 5, 7. Now I'm going to tell you in advance that this is something for which you might need a calculator. Because when we're finding this dot right here, it looks like it's not quite 1, and so it's between 1 and 0. It's going to be some kind of weird fraction or decimal. Sometimes having a calculator will be helpful for evaluating it. If I look at this slope, it looks pretty positive. Now, it's definitely going up on the x as it goes up on the y. So this is going to be a positive slope. And it's going to be a slope that's pretty close to 1 because it looks like it's going up 1 and over 1 with a little bit of extra. But to find out for certain, I'm going to plug it in this way. I'm going to call this my y1, this will be my y2, this will be my x1, and this will be my x2. To find slope, I'm going to plug these into the formula. M is equal to y2 minus y1 over x2 minus x1. All right, when I plug these in, it'll look like this. M is equal to, what is my y2? It's 7 minus my y1 is 2. Now, you might have been tempted to say 7 minus 5, but that's y2 minus x2. That does not work for this formula. So hiding that, 7 minus 2 over 5 minus 1. Seems like it makes sense. I've got 7 minus 2 is equal to 5 over 5 minus 1 is equal to 4. And I can check that against my prediction. My prediction was that I'd have about 1, slope of about positive 1. Now 5 over 4 isn't exactly 1, but it's pretty close. Remember, 4 over 4 would be 1 exactly. So 5 over 4 is a little bit more than up 1 over 1. Technically, it's 1.25, but we're going to use it as a slope in a fraction form because that's the easiest way to look at it. All right, our next step is to write the equation. For this, I need a little bit more room on the bottom of the page. I'm using the same points, and I'm using this slope. To write the equation, I'm going to plug it into y equals mx plus b in order to solve for b. I actually have information for y, m, and x, so I can just plug those ones in, and all that's left will be b, and that should be pretty straightforward to solve. Now to do this, I need to pick one point. I'm going to use this one because it looks easier. I'm going to use 1 and 2 for my x and y. So I'll just start with that. Let's say that y is 2, because that's what I have up here. And when y is 2, I know that the x value that goes with it is 1. What is my slope? Well, I can actually just plug this in directly. 5 over 4 times 1 plus b. What is my b? Now, if you're tempted to choose one of these ones, hold off on that. B is just b for now. We don't know what it is until we've plugged these ones in and solved. Now, remember we made a prediction. If I scroll back up here, we made a prediction that b was going to be pretty close to 1. Maybe a little bit less than 1 based on how that line looks, but somewhere around 1. All right. 2 is equal to 5 over 4 times 1 plus b. What is 5 over 4 times 1? Well, it's just 5 over 4. So we don't really need to worry about this 1. I'm going to go ahead and scribble that out a little bit. 2 is equal to 5 over 4 plus b. In order to get b by itself, I have to subtract 5 over 4 from both sides. Because this 5 over 4 isn't attached to any variables, I'm just subtracting it. If you were trying to multiply it out, you can still get an accurate equation, but it won't turn it into b by itself. Minus 5 over 4. These ones cancel. And finally, I'll have that 2 minus 5 over 4 equals b. What is 2 minus 5 over 4? Well, we could think about it like this. 2 over 1 is equal to 8 over 4. So 8 over 4 minus 5 over 4 is the same thing as saying 2 minus 5 over 4. So 8 over 4 minus 5 over 4, how many over 4 do we have left? We have 3 over 4. 3 over 4 is equal to b. Now, if you want to do this via calculator, you can. 5 over 4 is 1.25, and so you'd have 2 minus 1.25. 2 minus 1.25 is 0.75, and that's the same as 3/4. If that was a lot of information, you feel like it's brain overload, don't worry about that for now. We'll just focus on 3/4 is equal to b. The rest of that we can plug back in. So our final equation is y is equal to 5 over 4 times x plus 3 over 4.